Good morning, sixth grade. So this is for Monday, April 27th. So this week you guys are going to be learning about patterns of circulation in the atmosphere. The PowerPoint that I'm going to go over today is going to be used for today and tomorrow. It's in your in the folders in your in Edmodo with the schedule. So here it is, and then obviously the video, and then I'll link the videos in YouTube. All of your assignments this week will be on Pearson. You have 4 Pearson assignments this week, which I'm gonna go over today's just briefly really quick so you guys see what you have to do. So I didn't include any extra videos other than the 2 Pearson videos for you guys to watch today and tomorrow. If I do add any extra videos, I will post them in the library, and I will post them as a post on the Edmodo page. I'll probably do that tomorrow. So for today, you are going to, well, let's start with the standard that you guys are doing. You're going to explain how energy provided by the sun influences global patterns of atmospheric movement and the temperature differences between air, water, and land. The essential question is, how does the energy provided by the sun influence the temperature differences between air, water, and land? And students will be able to explain how energy provided by the sun influences the temperature differences between air, water, and land. So today you're going to watch this video. You're going to watch the video on Pearson called Patterns of Circulation in the Atmosphere. And then you're going to do the interactive activity Where the Wind Blows. And we have Zoom at 11. There is no Zoom tomorrow, no Zoom on Tuesday. So I put it in here. You guys should see a couple of other notifications to remind you, but there will be no Zoom on Tuesday. But on Tuesday, if you guys have any questions, make sure you just hit me up on a DM on Edmodo. Yes, I did just say that. Okay, so I'm going to go back to sharing for the PowerPoint. Okay, so why does this look weird? The PowerPoint is literally taken from your book. I pretty much copied everything from the book for the lesson for topic 4, lesson 2. So here we go. Patterns of circulation in the atmosphere. Okay, I literally just went over this, so I'm not going to read this again. Okay, so the vocabulary that you guys have this week are wind, sea breeze, land breeze, Coriolis effect, I think I said that right, and jet stream. There's some other words like global winds and local winds. Those are actually important words, but they weren't highlighted as vocabulary in the lesson. Okay, so causes of winds. Air moves away from high air pressure areas to low pressure areas. When there is a difference in air pressure, air moves and wind is created. Wind is the movement of air parallel to Earth's surface. Higher and lower pressures are results of unequal heating in the atmosphere. Air over the heated surface expands, becomes less dense, and rises. As the warm air rises, its air pressure decreases, but if another area is not heated as much, then the air in that area is cooler and denser. The denser air sinks and air pressure increases. The cool, dense air with a higher pressure flows underneath the warm, less dense air. This difference in pressure forces warm air to rise. Measuring wind. Okay, this is really tiny. Um, Wind is a valuable resource, and understanding wind can put this resource. Wow, I'm sorry. Wind is a valuable resource, and understanding wind can. I think that was supposed to say put this resource to work for us. Sorry. To identify winds, they are named. They are named. To identify winds, they are named using directions from which they originate their speed. A wind vane, which this is what this picture is, the wind vane, is helpful in seeing which way the wind is blowing. The arrow on the wind vane points in the direction the wind is blowing. Oops, I missed one. Winds can blow from any direction, any of the four directions: north, south, east, and west. They are named by the direction from which they are blowing. But sometimes they also say the winds are like north, northeast, or they're coming from the northwest or southeast, southwest. So they actually have all the directionals. Okay, continuing with measuring wind. So these pictures right here are I don't know how to say this word. Anemometer. Let's go with anemometer. Okay, so wind speed and pressure can be measured with an anemometer. An anemometer has, that's supposed to say three or four cups mounted at the ends of horizontal spokes that spin an axle. The force of the wind against the cups turns the axle. The anemometer tracks the number of rotations and that number is used to calculate the wind speed. Sorry, I'm just going through this really quick because I don't. Okay, I'm gonna go over local winds and part of the global winds today. Okay, so local winds. Winds that blow over short distances and affect local weather are called local winds. The unequal heating of Earth's surface within the local area causes local winds. These winds form only when the global winds in the area are weak. When sunlight reaches the surface of Earth, land warms up faster than water. The air over the land gets warmer than the air over the water. Cool air blows inland over the water and moves underneath the warm air, causing a sea breeze. A sea breeze is a local wind that blows from an ocean. There's also a lake breeze. I didn't write it in there. A lake breeze is a breeze that blows over a lake. At night, the land cools faster than water. The air above the land begins to cool and move underneath the warm air rising off the water. The flow of the air from the land to the body of water forms a land breeze. And global winds. So there were 2 pages for global winds. I'm going to do the second one for Tuesday. The patterns of winds moving around the globe are called global winds. Global winds are created by the unequal heating of Earth's surface. Global winds occur over a large area. The direct rays from the sun heat Earth's surface intensely near the equator at midday. Near the poles, the sun's rays strike Earth's surface less directly. The sun's energy is spread out over a large area, so it heats the surface less. As a result, temperatures near the poles are much lower than the equator. Okay, now I'm gonna go back to looking at your, I'm gonna log into Pearson so you guys can see what you guys are doing for tomorrow. What? I don't know why that did that. Hold on. Okay, so your assignment for this week is, I hope it posted. Okay, so you have to watch, for today, you have to watch this video here where it says patterns of circulation in the atmosphere, and then the interactive activity is where the wind blows. We're going to preview the activity really quick. Okay, so it's only 4 short slides. This one's super quick and easy to do. You have one question here, a second question, and a third question. Please make sure you guys get your work done for today. Later this week, you will have a virtual lab, so my video for that will be about the virtual lab. Okay, see you guys on Zoom. Bye.